Now, yesterday we stopped when we were looking at the definition of the equation of a line. Just a reminder that it's a formula that defines the relationship between the x and y values, the points that are on the line. And we looked at the line 2x plus y equals 4, and I was talking about what points satisfy this formula. So I was able to kind of work out by guessing if x was 1 and y was 2, then I would get 4, so I can say that the point 1, 2 is on the line. And I asked you, could you write down 3 other points that were on this line? Now, the easiest way to do something like this is to pick a value for either x or y. Pick a value for either x or y and sub it in and use algebra to calculate the other value. So for example, I might decide if y was equal to 4, what would x be? I'd have 2x plus 4 equal to 4. So 2x would be 4 minus 4, which is 0, and x would be 0. And that would tell me that the point 0, 4 is on the line. So that's a way of doing it. And you can use negative numbers as well. If y was equal to minus 2, then what we'd get is 2x minus 2 equals 4. 2x would be equal to 6, and x would be equal to 3. So the point 3 minus 2 is on the line. Well, we don't have to keep it just to subbing in y. We can do it the other way as well. So what about if x was equal to maybe minus 1? When we sub that in, we'll get 2 by minus 1 plus y equals 4. So the reason I was subbing in y was because it made the subbing in slightly easier. You get minus 2 plus y equals 4, so y is equal to 6. And the point minus 1, 6 is on the line. And that leads us to the next topic, checking if a point is on the line. So for example, is the point minus 1, minus 2 on the line? Let's pick a different line. 3x minus 2y plus 7 equal to 0. Okay, my lines don't always have to be in this format. We'll talk about the format of lines in a while, but my line will always have a formula with only x and y in it. That's how we know that it's a line. So what we're going to do is we're going to sub in x equals minus 1 and y equals minus 2. And if my equation balances, that means I've got the same thing on both sides of the equal sign. Then the point is on the line. Otherwise, it's not. Okay, so let's look at that. I'm going to sub in, instead of x, -1, and instead of y, -2, and we'll see what we get. You can just put that into your calculator in one go, or you can do it in your head. -3, take 4, is -7 plus 7. And is that equal to 0? It is. So therefore the point is on the line. What about the point? Is the point 2, 3 on the line? Well, if I sub in x equals 2 and y equals 3, do I get 0? Do I get a balanced equation? I've got 6 minus 6, which is 0. So this, when you put that in your calculator, you get 7 equals 0. And 7 equals 0 is a nonsense statement in maths, so therefore the point is not on the line. Okay, so hopefully that's nice and clear for how we check if a point is on the line or not. I said we were going to talk about the different formats that we write our lines in. So the header here is lines in the form y equals mx plus c. This is really, really important. Okay, it looks like a whole pile of gibberish, of course, because it's all letters, so we need to talk about what this represents. When you have a line in this format, everything apart from the x and the y will be a number. So I might have y equals 3x minus 2. That's an example. Or I could have y equals minus 2/3 x. You'll very often have a fraction here, and I'll explain why in a second, plus 3. When the line is in this format, it gives us two pieces of information. M, which we've seen before, is the slope of the line. And C, standing for constant, is the y-intercept. Now that's a new word that you probably haven't heard before. So M is the slope of the line and C is the y-intercept. Y-intercept is the point where the line crosses the y-axis. So we remember our axes. We have a line going up and down, a number line going up and down, and a number line going across. The number line going up and down is our y-axis, and the number line going across is our x-axis. Let's look at an example with that. So for the first example, write down the slope and the y-intercept of the lines. I'm going to use the two that we have up there. Y equals 3x minus 2 and y equals minus 2/3 x plus 3. So for the first one, the slope is the number in front of x, it's 3. And the y-intercept, we don't write it as a point actually, we just write down the number. But I might write it like this, y equals minus 2. And this one here, the slope is minus 2/3. And my y-intercept is y equals a plus 3. Sorry, that went off the screen there. Okay, we're going to have a follow-up question with this. Hence, graph the two lines. So hence is a word that we love in maths questions. Hence means using your previous answer. Using your previous answer. Okay, well, for the first line, I know that its slope is 3. Now, slope is rise over run. So what I really need is to write this as 3 over 1. That'll make it easier. And my y-intercept is minus 2. That means it goes through the y-axis at minus 2. I'm going to draw them both on the same axes. Hopefully this is big enough and clear enough for everyone to see it. So again, my y-axis is always going up and my x-axis is always going over. 1, 2, 3, 4, 5. I'm going with 2 boxes just to make it clearer for the video. But you can use however many you want. 1, 2, 3, 4, minus 1. The important thing is that our numbers are right on a line. They're never in the middle of a box. Minus 3, minus 4, minus 5. So for the first line, the information that we have is that the y-intercept is y equals minus 2. So that means on this axis, it's my y-intercept. And now I'm going to use the slope. So I said the slope is rise over run, which is 3 over 1. That means every time I go over one space, I must go up 3 spaces. So I start from the y-intercept, I go over one space, and I go up 3 spaces. So over 1, it's a positive slope, and up 3. And I end up here. Okay? So what I've done there is I've drawn the 2 sides of the triangle that we talked about yesterday. Then all I have to do is join those dots together, and that will be the line. I didn't have a name for this line, so I'll just write its formula next to it. It's the line y equals 3x minus 2. Let's do the other one. I'm going to use the same axes here. So the second line had a y-intercept. So we start with the y-intercept, had a y-intercept of 3, a plus 3. There's my y-intercept. And my slope. Now my slope is negative, so it means that it's going down. It's rise over run, but I'm going down. So this means that I'm going to go, so minus 2 over 3 means I'm going to go over 2 and down 3 instead of over 2 and up 3. I start from the y-intercept. Now I've used 2 boxes. So to go over 2, I'm going over 4 boxes, right? That's my run of 2 spaces. You can see that I'm above the 2 point there. and then I need to go down 3. 1, 2, 3. 3 down like that. And I actually end up this point here. So I've drawn my 2 sides of the right angle triangle and I join those together. And that's going to be my second line. You notice we don't just stop at the points because lines go on forever in both directions. So this is the line y equals minus 2/3 x plus 3. Okay, there we go. And hopefully that's nice and clear for you there. Thank you very much, and I'll put the homework up in Google Classroom for you as well. I'll talk to you not tomorrow. Your next class will be on Monday. Have a lovely weekend and well done for all your hard work this week. Thank you.